Good morning. How's everybody doing? Is everybody doing swimmingly? It's time for lunch. Who wants lunch? Lunch? I'm hungry. Friday is very bing chilling. Very good. Very good. There we go. Very good. All right. You just ate dinner? Why would you eat dinner? It's lunchtime. Jeez, how dare you be in a different time zone? How dare you? How dare you? All right, so we should have the Transporter-4 mission today. Probability of violation went down to 40%. So we should... Well, we might see something. They've started fueling. Well, it's been fueling for a little while. But new Minecraft update. I'm not clicking on links today. That's not happening. And I don't trust you. Okay? The SpaceX stream is online. All right, let's go over there. So we got a reused booster today, which is that's pretty neat. That's good. Andrew, you got your first career pitching win. Went 4 2/3. No earned runs. 9 Ks on 80 pitches. Hey, all right. Andrew, not bad at all. Not bad at all. 9 Ks, 4 2. That's not bad. Zero earned runs, man. That's what counts. Sweet. Scroll back to Sir Crumpet's deleted message. Yeah, I did, and I replied to him. I don't know where you were, mate. I'm not clicking on nothing today. No, hell no. I don't trust you guys. I ran out of time. I was gonna play, it's not like I can play Tarkov as a joke or something. It's a pretty bad recurring joke. Ishigu, just spent the week at a high-speed rail conference. Looking forward to the launch today. Sweet. Sweet. You could play Fork Knife. It's not even funny as a joke, Rav Shark. You could do like Matt Lone and play RSS. Nah. Who are you kidding? Your Tarkov play as a joke. Walked into that one. Play Farming Sim? No. What are we transporting? So this is a rideshare mission. It's over 40 satellites. This is a bunch of small sats. So basically what these... Here, let me flip over. What these transporter missions are is basically where SpaceX takes a bunch of different payloads, a bunch of small payloads. They're not very big. They're like shoebox-sized payloads. And literally puts them on a Christmas tree payload adapter. Right, it's quite literally a Christmas tree. It looks like a Christmas tree, and they use one Falcon 9 and they launch it. Now, where's this Falcon 9 going, and what is it doing? So this one's gonna go on a polar trajectory out of the Cape. It's going south. It's gonna go down south around Miami. So it's gonna be like the Cosmos Sky. The same trajectory as the Cosmos SkyMed satellite. So the one that we had really good pictures of. I'm not sure if the pictures are going to be as good as the last one, but this one is pretty cool. Which booster is it using? I have to look. 1061-7. This booster supported Crew 1, Crew 2, Sirius XM8, CRS-23, XP, and Starlink 4.7. So this booster has launched people 2 times. It's launched 3 Dragon capsules and 4 NASA payloads total, including the Infrared X-ray Polar Observatory. So, yeah, should be pretty good. And guys, when I say this thing looks like a Christmas tree, I'm not kidding. This looks like, it's like, oh, I got 3 or 4 Kerbal missions, 3 or 4 commercial contracts for these small satellites. Here, let me just stack as many satellites as I possibly can inside of the payload fairing. Look, take a peek. There it is. Look at all these little guys. Look at all these little things. So busy now. These are all a bunch of little satellite, and dispensers and stuff, and then there's some stacked on the top. Yep. Ooh, new SpaceX opening.
Stage separation confirmed.
Ooh.
Dragon separation confirmed.
AC! So much room for payloads.
Stage 1 is transonic.
Oh, wow.
Landing legs have deployed.
Well, this is neat. Oh, there's a Starship landing in there.
You're looking at a live view of the Falcon.
All right, I kind of want to see it again. Hold on.
Ice launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has
7,
started.
6, 5, 4, 3, 2, 1.
Go for launch.
Oh! 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 Oh!
Vehicle is supersonic. Stage separation confirmed. Dragon separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Okay.
A full list of today's deployments.
Okay. All right. Let's fast forward, make sure that we're caught up here. Hands? No, we're good. Just fast forward the cast here. Prepare to fast forward. Fast forwarding, sir. Yes, controlled explosion. Nice. G-Funky with 11-month resub. Cool. Neil deGrasse Tyson is coming to town with this week. What should I ask him? I don't know, man.
Parts of the Earth's atmosphere. For today's mission, it will be flying a southern trajectory along Florida's eastern coast, which may make...
Ask him to explain what a rectilinear halo orbit is. Do that, Alex. That'd be awesome.
Stage 1, RP1 load complete.
Back down to Earth. We just finished stage 1 fuel loading. And
Okay.
again, the first and
They're
second...
spraying down water on the drone ship here. That basically film cools the drone ship. They put basically a puddle on the drone ship. When the rocket comes back down, right? The rocket exhaust heats up the water and it turns to steam instead of melting the drone ship. Also, interlace picture. Very nice. Let's see.
which will take the
get
40
you way up
spacecraft to their eventual destination in orbit. You may want to watch the velocity gauge that'll show up on the bottom left of your screen to see how fast we're going when stage 1 separates, and then how fast when we shut down stage 2. You'll see that stage 2 actually contributes more velocity than the first
That'll be
stage.
fun.
Now, right now, the spacecraft are enclosed inside the large nose cone at the top of the rocket. This is called the fairing. The fairing's job is to protect the payload inside until the vehicle is outside the Earth's atmosphere, at which point the fairing halves will separate to expose the satellites to space. Now, today we're flying a new fairing, which you might be able to tell as it's much cleaner
for strong back retract.
Okay.
than the sooty first stage, which is
Man,
flown.
those countdown loops, we can't hear those. No, did you see there? Actually, the count... Did anybody else notice that they're piping in more countdown loop than they normally do? Who said you will destroy crappy launch video broadcasters, not join them? Yeah, yeah, we got it. We can't watch this, guys. Sorry, we can't watch this.
Minus 3
Strong
minutes.
back retract has started.
Heard the call out that the strong back has begun retraction of the transporter erector.
Could they double the
You
transporter
can see those
payload
clamp
capacity if they
arms
wanted to, or is
below
it at
the
max?
fairing opening there to allow the transporter erector strong back to pull.
What do you mean, Sile? Could they double the transport? It depends on where the rocket's going, man.
The structure that provides liquids, gases.
It really does depend. Rain and thunder 40 miles south, so no way I'm seeing anything on this one. Got it. It looks a little cloudy down there today, WD. I know this weather. I know this weather. Let me guess. About 65, 70 degrees, somewhere in there. Not terribly humid, but still humid. Yeah. I know this weather. I went to school many times in this weather, in the very early morning.
Transporter-4, which is our 4th dedicated rideshare mission to date. The payload.
It's going to 650. Yeah, no, this one's going way up there. 650 SSO.
Stage 1 liquid oxygen.
Stage 1 LOX load complete.
There it is. We just finished.
It's
Stage
noon.
1 liquid oxygen.
Oh, well, Spoon. Never mind then, you know, because it can only be this weather in the morning.
Well.
70 is about 30 C. No, 70 is closer to 20 GSF.
As late as possible so we can keep it as cold as possible so we can load more of it into the booster.
When is the next crew mission? The 6th, Cooking Fat Axiom 1. First commercial mission to the space station. Yeah, that's a big deal. That's literally 5 days away. This is Drone Ship Human. It's a polar launch corridor out of the Cape.
That it is a busy morning here on the factory floor here in Hawthorne, California. We're about 10 seconds from the end of stage 2 liquid oxygen.
All right. Let's see. It's still 40% POV. And if you may talked about it, I missed it. Sorry. I missed it. That booster has launched people 2 times into space.
Stage 2 LOX load complete.
Just thought I'd let you know.
There's the call out for finishing up liquid oxygen loading.
Okie dokie.
Those white clouds that you see coming
T
from
vent.
the booster are venting from the transporter-director liquid oxygen line. They're on your right. That's totally normal
It's cool
and
and fun.
expected.
Yeah, it's our
In about 30 seconds here at T-minus 1 minute.
Gas closeouts started.
more or less Tessa, yeah.
At T-minus 1 minute,
There's your gas
Falcon 9 will
closeout.
be in startup. The first and second stages will begin pressurizing for
Собаки,
launch.
слечу.
The internal flight computers
Rocket
will have
go
taken
brr.
control of the countdown.
All right. So what they're doing is they're evacuating all the liquid oxygen, well now gaseous oxygen, out of the fuel lines that go up to the second stage in the transporter erector. That's the truss structure
Falcon 9
that's
is in startup.
sitting next to Falcon 9. You don't want fuel in there. You want fuel in the rocket. Yeah, I know. I know. Shocking revelation. Am I safe here? This isn't a joke.
Falcon 9, Transporter-4, LD is go for launch.
Launch director reports go for
LD
launch.
has given that final go for launch. All systems are go. Let's watch Falcon 9 lift off.
T-minus 30 seconds. Second
T-minus 30 seconds.
Second T event. Huh. 20. Jet, go for launch. Jet control.
T-minus 15
This is
seconds.
Strimmer. Strimmer is go for launch. I guess so, goalie.
10, 9,
Sound suppression system
8,
should turn on
7,
here. Yep, there it goes.
6, 5, 4, 3, 2,
Engine ignition.
1. Mission and liftoff of Transporter-4.
There, I guess she's going. There we go. Let's go. We fly today. All right.
Pitching downrange. Stage 1 chamber pressure is nominal.
Okay, propulsion. The propulsion guy says the engines are working just fine. Yeah, through the clouds. That's cool. Look at that. Let's go. Man, there's a lot of cloud cover today. Jeez. Dude, look at the hole it put in the clouds. Oh, that's so cool. It punched
We're
a
at
hole
T
right
plus
through the
40
clouds.
seconds. Awesome views from Falcon 9 punching through the clouds.
Hey,
Falcon 9
that's
is
my
keeping
line.
power, and we're
Power
currently
and telemetry nominal.
throttling
Damn it,
down
Yume.
in preparation for max Q at T plus 1 minute and 12 seconds.
She stole my
This is where the
line.
stage will experience the maximum aerodynamic pressure.
Why? What was the potential violation? Thunderstorms, man. A lot of thunderstorms down there today.
There's max Q. Everything is looking good with stage 1
Drone
trajectory.
ship. Grab shark. Yeah, Paul,
Beautiful
speculations.
view of the
Don't worry
clouds
about
in the
it.
background there. In just about a minute, we will have 3 events coming up in pretty quick succession. There's MECO, which is main engine cutoff.
Depends,
Stage
Nino.
separation, which is when the first and second
They lurked in
stages
chat.
separate. And SES1,
Sure
where
they do.
that single MVAC engine on the second stage will ignite, carrying
Start of MVAC engine chill.
Okay, now they're starting to put
the
propellant.
call out for the start of that MVAC engine chill prior, getting ready.
They're basically priming up the fuel, the second stage rocket engine. They're basically getting it full of fuel to make sure that it's cold enough to handle the propellants and to make sure that when they go to start it, it has fuel to start. The reason why you don't want propellants in your second stage, like when you go to launch, is because the propellants, you're using liquid oxygen and kerosene. Kerosene's not a big deal, but liquid oxygen is super corrosive. So you really only want that in the rocket engine, like right before you fire it and while the engine is going. They'll purge down the second stage engine at engine cutoff here. So stand by for main engine cutoff. Watch, you're looking up the business end of the second stage. You're gonna see it jettison out. And no, I've watched this like hundreds of times. It never gets old. It's
Main
really
engine
freaking
cutoff.
cool. Ready?
Stage separation confirmed.
Let it rip. Stiffen ring separation.
MVAC ignition.
Good. Perfect.
There you heard and saw those
Textbook.
3 events happen back to back: main engine cutoff, stage separation, and second engine startup 1. You can see those grid fins deploying on
Textbook.
the first stage there. In just a few seconds, we should have
Fairing
fairing.
separation confirmed.
Watch, ready?
There's that confirmation of fairing separation.
See ya. Yeah, see? All the satellites. It's a big
The
Christmas
2
tree.
fairing halves have separated from the vehicle, exposing the 40 spacecraft to the vacuum of space. Now, today's mission marks the first flight for both of those fairing halves, and we will be attempting to recover
Nah,
those
Jacobs, this is-
from the water once they fall
This
back
is life,
down
man.
to Earth.
This is great. I watch this every day. We almost do.
Now, we're currently in our
No,
first
Sushio.
of 3
I don't think
MVAC
so.
burns. Now, this first burn should last until about T plus 10 minutes.
I mean,
And the next
Swish, think about it this way, dude. Okay, so do you pay for gas for your Uber or for a taxi? No. It doesn't. See, so first of all, rocket payload contracts are or payload launching is contractual. Okay, so they might. I don't know. It really depends on what the contract says. However, fuel costs are such an inconsequential cost compared to everything else that it takes to launch and build a rocket that it probably isn't even a big deal. I mean, honestly, it pays to make a rocket that's more reliable so you don't scrub, because that is money lost, right? And SpaceX basically making sure that they can launch in basically whatever. I mean, this is Falcon 9's very quickly becoming like Soyuz, no fricks given, launch in whatever. I mean, this thing just launched into it didn't launch into a thunderstorm. There were thunderstorms around it. But see, in Florida, guys, down there, you can still... lightning doesn't go from, like, sky to ground in Florida. Lightning goes from sky to wherever the frick it wants to down there. It just... There's so much condensation up in those clouds that, you know, lightning can just travel from cloud to cloud to cloud. Even if there's a thunderstorm like 20 miles away, you can still get a bolt that goes across like 4 or 5 clouds to a place where it's not raining, right? And it could still hit it. You got to be careful with that. But I mean, it's very clear that was not an issue here. But that didn't happen here. This Falcon 9 had positive traction. Can't make these marks without positive traction. So it's very, very, very... Falcon 9's like weather, it's called a weather envelope, is very, very wide. Falcon 9, grid fins wide. Look how high that first stage is. Yeah, this mission is going to a higher orbit, and then they're actually going to go down to a lower orbit. The initial insertion orbit, it's a very interesting mission. This is not something that we usually see. I had to go read about it because I was wondering. It's going to go... to like a 640 by 655 is what they're aiming for. That's really, really high up there for Falcon 9. That tells me that the payloads are pretty light. And then after that, it's going to go to 490 by 510 at 97.4 degrees, so sun synchronous. But it's going high first, right? And then going down, which is very... That's a weird trajectory, but I'm sure there's a very good reason for it. They're probably maximizing the delta V of that first stage and boosting the stage higher with the first stage, so the second stage has more fuel to go to a bunch of different orbits and then deorbit itself. Yeah, it's pretty cool. Oh, and there's the Bahamas down there.
Entry burn, which is about a 20-second burn. That
Seriously,
that first
it's the Bahamas,
down,
and there's Florida right there.
the Earth's atmosphere.
There's that looks like Boca Raton right there in Fort Lauderdale.
Acquisition signal, Bermuda.
Seriously, that's really cool, actually. Where are they landing the first stage? It's going to be out on a drone ship south of Miami, between Miami and Cuba.
Now, for today's mission, the stage 1 landing burn will...
There's only one burn on the second
under a
stage
minute
per the flight
after the
timeline.
end of our stage 1 entry burn.
That's not what NSF is saying, dude.
And that'll land the first stage on our drone ship. Just read the instructions.
Unless NSF got it wrong. I have the NSF article up here.
Of the landing burn into perspective.
I wonder what the lowest temp that they can launch in is. Neuro, if I had to guess, I would guess that colder temperatures are probably more preferential for Falcon 9 because of the densified propellants, but it is not that simple. It is not that simple. All it takes is one part getting too cold, and then the whole thing can come. Boop, boop. Yeah, but I don't want to say that while the mission's actually going on. We'll talk about that when the mission's done. First stage should be coming in here. Should be getting up on the entry burn. Best part of my day right here. Best part of my day. Supersonic retro propulsion. So Falcon 9 is going to fire the engine here, and it's going to slow down the first stage when it's coming back in. But the coolest part about this is if you notice the first stage doesn't have a heat shield. It is up in space. It's way up there, like 500,000 feet up there. What it's going to do here is fire its engines, and its engines are going to... The gases from the engines push the re-entry heating away from the vehicle. And it actually puts Falcon 9 in a nice cool column of gas. See? There it is. Oh, that's so freaking cool, man. That's the heat shield. You can physically see the heat shield right there. Yep. Now, that's pretty cool. That's pretty cool. Supersonic retropropulsion. Supercalifragilistic retropropulsion. What? Yep, there it goes. That's the entry burn. That's a long entry burn. It's a longer entry burn because this stage went higher. Because it had a higher apogee, so it went further away from Earth, right? It's going to come down with more kinetic energy. You're going to need a longer burn because you're going to encounter more re-entry heating. Grid fins should be steering this sucker in. Looks like Falcon's combating some windage there. Uh-oh.
The first stage has just one more burn left.
Terminal guidance.
That's the
Stage 2 is in
burn.
terminal guidance, so it's on closed
Just
loop.
a few seconds. And at the same
She was
time,
really fighting some windage there. You see that?
MVAC will actually shut off at the same time as the start of that landing burn.
Okay, listen for the flight director and the launch director. Or, well, flight director. Where they landed. It's out on a drone ship, Ellie. Okay. Booster officer reports landing burn. Stand by for the call for leg deploy.
Discovery, go at throttle up.
Seco 1.
Second stage engine cutoff 1 is
There's
confirmed.
second engine
purge
cut
down.
off 1, and you heard that we did start our stage 1 landing burn. This is about a
Here we go.
20-second burn
Here we go.
of the single.
Come on.
Insertion.
Oh, that's a little steep. Dude, that thing came in real quick. You see how fast that thing came
As
in?
you can see,
Damn.
we did have a successful landing of our first stage as well as a
Tank
confirmation
crusher
of a nominal
vent down.
second stage orbit. in
Look
the
at
middle
that
there.
trajectory, man.
Now-
Oh, that's so
Now,
cool.
coming up in about 5 minutes, we are expecting the start of the deployment sequence. There will be
That's
20
beast.
deployments of 40 spacecraft, which will occur over a 73-minute period of time.
That's
now,
cool.
This includes CubeSats, microsats, picosats, non-deploying hosted payloads, and an orbital
What's this
transfer
one?
vehicle carrying spacecraft to be deployed at a later time. Now, as I mentioned at the start of the webcast, due to the lack of the ground...
Why do they have a Starlink trajectory loaded in on the map screen? Anybody notice it? Whoa, hello. So right here, what's going on is some outgassing. The second stage reaction control systems use cold gas thrusters. They basically, you guys know that the thing that you use to clean the keyboard, literally that, but with nitrogen. There's second stage thrusters here, and when the gas gets put into the vacuum, it turns solid immediately. So they're using nitrogen, and they outgas that nitrogen, and it turns to solid nitrogen instantly. That's what all those snowflakes around the payload look like. That will not look like. That's what they are. So you see all that. You see, it looks like snow and ice going around. It's from the second stage using its RCS to steer the payloads. You clean your keyboard, dude. This keyboard gets a lot of use, man. Yeah, absolutely. My guess is the escape route if something went wrong. I don't know. Axiom is in 5 days. A little hot at staging. Landing burn be a little early, right? Yeah. Our calls are going to be a little early. Going to be slightly high at staging. Negative seats. You don't clean your keyboard? Man, I clean my keyboard. I take hand sanitizer and a Q-tip and clean it because I actually haven't done that in a little while. But yeah, dude. With how much use this damn keyboard gets, dude, think about all the use that keyboard gets, man. Yeah, no, it'll get dirty real fast. Did we miss the booster landing? No, they showed it. Here, would you like to see it again?
Where we
Watch this. We had undisrupted footage. Oh! That's nice. that's pretty neat.
We did have a
So they vented down the tanks from flight pressure. That's what that is going on there. And then you know if they show the stage again, you should see some venting coming down from around the thrust structure on Falcon 9. What they're doing is they're purging out the liquid oxygen. Like I said, you want to get all of the liquid oxygen out of those motors as fast as you freaking can. Liquid oxygen? I know. Okay. All right. How can our eyes be real if the universe isn't real? No. Liquid oxygen oxidizes things very badly. Oxidization is rust and corrodes things. Yeah, that's not good for metal. So, I know. Shocking revelation there. So, what they do is they shoot in the engines, they shoot helium into the engines, gaseous helium, like the balloon. They shoot that because helium is inert. It's not really non-reactive, I guess. Like it's an inert gas. They shoot it in there, and it gets all the oxygen out of the engines, and it dries them out to make sure that they don't rust from the inside out. Yeah. So they do that with the second stage too. Right after second stage engine cutoff, I'll show you guys if you want to watch the replay. The engine shuts off, and then they hit the thing with helium. Helium on Falcon 9 is used as what's called an ullage propellant. Who you calling a nerd? Oxidization, corrosion, rust, bad for you. Whoa, no way. I know. Yeah. So let's see. I'm wondering if we can see the engine purge down. No. Oh yeah, you can see a little bit. In other news, during the launch, the crew access arm retracted ahead of the SLS wet dress rehearsal. Cool. All right, so check this out, fellas. These transporter missions fly in a very, very cool trajectory. This is the polar orbit launch corridor out of the Cape. So usually in the past, the U.S. launches out of Vandenberg, which is over here, to go on this type of trajectory, right? But SpaceX with Falcon 9 proved that they can do it. And they reopened this polar launch trajectory that hadn't been used since the late 50s. The reason why it hadn't been used since the late 50s is because there was a Thor Delta launch that went out of the Cape that launched on a trajectory like this in the 60s. And the stage landed in Cuba. In the early 60s. Yeah, no, not a good idea. Nope, that's not a good idea. So they suspended that launch corridor for a good while. Nowadays, it's not as bad, you know? Yeah, Thor Delta, which is derived from the Thor IRBM. Yeah, nope. The Air Force is like, yeah, how about we don't do that? How about we don't do that? The stage actually landed on a cow and killed it in Cuba in the early 60s. Okay, all right. Yeah, so this corridor hasn't been... SpaceX reopened it, I think, what was it, 2019? And if you look, Falcon 9, what it has to do so it doesn't fly over freaking Miami, it has to go out to the southeast, right? And then the first stage has to take a right around... It has to go around South Florida and then fly over Cuba. And the drone ship is between Florida, the Bahamas, and Cuba, out in the middle of the ocean. And they land the drone ship... They land the Falcon 9 on the drone ship out there, and the second stage flies over Cuba. But if you look where stage 1 is, right? Look where it is. It's close to Cuba. So you got to be careful with the staging trajectory here. I don't want to play Hearts of Iron right now, John. Old World Blues and stuff is cool, but I don't think that playing Hearts of Iron is particularly in good taste right now. But yeah. No, I haven't, S-Master. Interesting, though. Is that... Wait, have I ever watched Fog of War 11 Lessons in the Life of Robert McNamara? That's about the whiz kids and stuff, right? Robert McNamara was really cool until he started getting into politics, and then... not so much. Can you go back to T+436 and tell us about the Space Snake? Yeah, sure. What do you want to know? It could be solid oxygen or solid nitrogen. Here, I'll show you. You're talking about staging here, right? Okay, that right there is solid nitrogen. It's from the attitude control systems. Falcon 9's first stage, just like the second stage, has a cold gas thruster in it. The cold gas thruster is right there. It's a little nubberino, and when they have nitrogen at high pressure hit the vacuum, which is extremely low pressure, really quickly, it very quickly goes from gas to liquid to solid. In fact, the liquid window is like nothing. It just goes from gas to solid, and that's the residue from it. That's what all this stuff is. Yeah, these payloads. Look at the trajectory, fellas. I think we're between ground stations right now. They should get an AOS through Maldives. Not Maldives. There's one down in Maldives is over there. There's a ground station down here somewhere in Argentina, I think. The scientific term is resublimate. You're a resublimate. Got him. You're right. But if you look at these trajectory, this trajectory is that's way up there. 648 kilometers, that's above 400 miles. That's a long way, man. Yeah, Meccarine. I forget what the name of the station is down here. It's not Maldives. Maldives is over there. And they have a ground station there. I forget where all their ground stations are, man. I know they have one in Bermuda. They have one in New Hampshire. Yeah, they have one up in New Hampshire in the mountains. It's kind of cool. Maldives. What'd you say about me? I don't know. Forgive me if I'm not saying that right. I only speak 2 languages, English and bad English, okay? Yeah, look at that. It flew down over El Salvador, Honduras, Panama. Negative. I am a meat popsicle. No. I'm wondering if and why they can't use Starlink as a telemetry data relay to an appropriate ground station. I don't know. Some angry Ferrari Italian. Yeah, that's right. Synerd, I don't know. I'm sure there's a good reason. My guess is that Falcon 9, Starlink is not. There's not enough satellites to be able to track the thing. The coverage, they could probably do it. They could probably get coverage through Starlink, and we know that the drone ship has Starlink antennas on it. But it's probably for the. If I had to guess, this is a shot in the dark. I have no idea. If I had to guess, it's probably because they. If I had to guess, it's probably because they have trouble tracking moving things with Starlink right now, but that's going to change soon. It's for the same reason why you don't tape a Starlink antenna to the top of your car and drive around. It won't work very well. You'll get spotty coverage. And if it can't track a car going going 100 kph down the road, then it ain't going to track the rocket. The rocket's going a little faster than that. I meant for the upper stage. So right now, the upper stage is above the Starlink satellites by about 120 miles. Yeah, so that's... I don't know if the Starlink antennas can turn around and look the other way, but, yeah. It's a little bit higher than that. I think that the reason would be for the FCC. Maybe, I don't know. Is that a satellite going across the screen at T plus 838? Unlikely. Very unlikely.
Stage 1 entry.
No, that's just solid nitrogen. See? See, it's a flake. It's from the outgassing, fellas. Yeah, I know. I want to believe. Could they use tracking data in relay? They do, Right Flyer, but they only do that for NASA missions because TDRS is NASA's satellites. They wouldn't use it for a commercial mission like that. I mean, I don't see why they couldn't, but they won't. Oh, there we go. We had an acquisition. Did you watch the telemetry change? See 648, 27, 435. Watch. Ready? There's your acquisition of signal.
And acquisition signal, Punta Arenas.
Punta Arenas. Punta Arenas. Fast forwarding. Prepare to fast forward. Fast forwarding. Fast forwarding, sir. Interesting, Ellie. Look it. In human space program, you can fizz warp. You can fizz warp and it doesn't mess with the simulation. Man, human space program is really good. Really good piece of software. Yeah, 655. 655, 27, 402. That's way up there. Okay. If SpaceX didn't have a signal and needed to talk to the stage in an emergency, is it possible? Like, can they request NASA to use their satellites? It really... Van, you know what? That really depends on what they're doing.
And back engine chill.
Okay, they're gonna prime the second stage engine again to bring it down to the right temperature so they don't flash freeze the motor. And it's also because they dried the engine after second stage engine cutoff. They purged it out with helium, like I said. Now they're gonna put fuel back into it. Even letting the liquid oxygen stay in it for like 20 minutes, still bad for it. Yeah, liquid oxygen makes things rust real fast. It oxidizes things. I know. It's crazy, right? Crazy. Does NASA even rent out TDRS? They use TDRS for TDRS missions. Guys, I guess if the poop really hit the fan, then SpaceX could do it, but it really depends on the mission. I don't think NASA's gonna let them use TDRS to save a commercial mission. I really don't think that would happen, but, you know, you never know. I know, Dr. It's so strange, right? This burn will be about 2 seconds. Stage will enter another coast until T plus 1 hour and 8 minutes, where we'll perform a burn lasting 1 second. Yeah, Thomas, three burns. 3 burns, 650 kilometers, and then it's going down. And then it's going down to 490 by 510. This is one hell of a mission. This is a complicated mission, dude. They need to put that second stage, because it's putting up these small satellites, right? These little tiny satellites don't have enough thrusters to boost up to a crazy high orbit, right? So the second stage is going, like, if you think about, like, the second stage like an elevator, it's going to, like, floor number 7, and then it's going to 5, and then it's going to 4, and then it's going to 7 again. Like, the second stage is going to all the different floors. They pushed all the buttons on the elevator. And then hit the door, closed, and walked out. Don't do that. I've done that? You are a horrible person. Oh my goodness. I know. Not that guy, pal. Alright. So, watch right here. Look. You can see the oxygen that they're putting into the motor. Yep, there. It was crystallizing. That's cool, man. Interesting, Synerd. No, Tessa. Seco 1 got it to 640 by 655. And then this burn's actually going to bring it. This one is the circularizing orbit. Or no. Shutdown reaches final over measure. Falcon 9 will deploy 3 payloads shortly after reaching orbit. Once they are deployed, stage 2 will coast for 11 minutes before second stage engines start. This burn will last 2 seconds. After another 40-minute coast, stage 2 will burn its engine for the 3rd time for just 1 second to place itself into a final 490 by 510. Okay. Yep. See? They're chilling down the motor, and then the reason why the... Okay?
And back ignition.
Cool. Everything looked good there. Here, let me rewind it.
And back shutdown.
Okay? Stand by for the call for NOI. See, now they're
orbit insertion.
Good. See? They fired the engine, and then what they do, like, I'll show you that engine ignition one more time. Watch. They're purging down the engine, so once it's full of liquid oxygen, once they primed it, they'll fire it, right? And then they shut the engine off, and did you see all the valves opened? And they're immediately beginning the purge down. Once again, what they do here is they shoot helium or nitrogen. I'm not sure which one it is. I'm going to guess it's probably helium, but I don't know for sure. They're going to shoot helium into the engine to clean it out, to dry the engine out. They want to get all the oxygen, and liquid oxygen primarily. Gaseous oxygen is not that bad. They want to get all the liquid oxygen out of that motor. And that's what that vent line was on the side of the stage.
Eastern time from Cape Canaveral Space Force Station, had a successful stage
because of
operation,
corrosion.
Landed our first stage.
That's right, Elia. Remember, SpaceX needs to reuse this. They need to fire the stage multiple times, and then on the first stage motors, they have to reuse those. So you got to dry the engines out. You really have to, or you're gonna have a bad day. The engine won't fire again. It'll rust from the inside out.
Spanning across 20 deployments. Our first 3 deployments a little bit earlier than expected. Our first payload, which was situated at the very top of the stack, is an Earth observation satellite named NMAP which is short for Environmental Mapping and Analysis Program. It's the first hyperspectral satellite developed and built in Germany on behalf of the German Space Agency. By recording a spectral fingerprint of the objects under interest over a continuous spectrum of the sunlight reflected from the Earth, this technology offers new possibilities for rendering the invisible visible, providing identification of minerals or pollutants in a certain area, types of vegetation in selected areas, and how polluted a body of water may be. Again, we did confirm our first 3 deployments of the payloads. Up next, we are waiting on the relight of our second stage engine for its final burn at about T+1 hour and 8 minutes. We'll see you back here just before that to show that live. For the next 10 minutes or so, enjoy the space tunes and the intermittent views from our stages and our second stage, and we'll see you back soon.
I mean, give us a first stage view, you may. Stages. She said stages. She did say that. So, Phone Sister, can you explain rocket tanks? What are integral tanks? Integral means that the fuel tank is part of the structure. What Van said is right. All rockets use integral tanks. They haven't not used an integral tank since like the 40s, man. Phone Sister, it's all about saving mass. All right. So if you can incorporate your structure into your fuel tank, right? That's less rocket on your rocket and more fuel on your rocket. Less rocket on your rocket, more fuel on your rocket. Rocket goes further. Simple as that. Also, it's pretty nice shot right there. Balloon tanks for Atlas. Balloon tanks are a little bit different. Balloon tanks are an integral tank. Most rockets are. The balloon tanks, though, actually, with the balloon tanks, I would call balloon tanks not an integral tank now that I'm thinking about it. They don't use the tank wall to hold the rocket up. They use pressure inside of the tank to hold it up. So, Phone Sister, the balloon tanks that are like that were on like an Atlas SLV-3 or Centaur 1, Centaur 2, Centaur 3, Centaur 5, the balloon tanks actually are not integral structure. Centaur can't stand up. It cannot stand up straight unless the tanks are at pressure. The pressure of the propellants or ullage gas or whatever inside of the tank is what holds that thing up. Balloon tanks work a lot like a soda can, right? It's a green can here. Let me get this one out. They work a lot like a soda can. When there's nothing, when it's open, unpressurized, you can crush this thing really easily. Try to crush one when it's full. It's a lot harder because it's way stronger because the pressure is providing structure. That pressure pushing out uniformly on the tank wall means the tank kind of stretches out like a balloon and it makes it really, really strong. Once again, the less rocket on your rocket, right, the further it'll go. If you can minimize dry mass, maximize wet mass, you get more delta V. You have your rocket can go further because it's moving less mass with more fuel, right? So balloon tanks are really good for less dense propellants, right? Yeah, for the most part. Wait, how do they maintain rigidity if fuel is used? Good question. That's called ullage propellants. So, you have to keep the pressure non-dynamic. The pressure has to stay static on a rocket all the way up in its fuel tanks. That doesn't matter what rocket it is, to be honest with you. It's not just for balloon tanks. It's not just for integral structure tanks. You have to keep the pressure delta is a very low. It's a very small nominal window for a rocket. So, how do you keep the pressure inside of a fuel tank when your fuel is draining at like 1,000 liters a second or something? It's not that. I just made that number up. It's just hyperbole. How do you do that? Well, Phone Sister, what they do is they have composite overwrap pressure vessels. So it's basically, think like a propane tank, right? That's wrapped in carbon fiber. And the carbon fiber, along with the tank structure, makes it so that you can hold propellants or you can hold whatever in there at an extremely high pressure, gases mostly. So these composite overwrap pressure vessels, they look like a scuba tank bottle, basically, or a propane tank, or like a welder tank. Like if you have argon in a welder, they look kind of like that. They come in all different shapes and sizes, just like any pressurized tank, right? So those are actually inside. They're inside of the fuel tanks, mounted to the wall on the inside of the fuel tanks, right? And what happens is, as the propellant drains, those valves open on the tanks, and they pump gases into the tank. It's usually helium. Usually it's helium. It doesn't matter what rocket it is. They launch helium because of its low mass. And it's also helium's inert. So that pumping the gas in while the water drains out keeps the pressure uniform in the tanks. The pressure has to stay the same every time. Are the SRBs on SLS or SDS pressurized rockets? SRBs, Trojan? Yeah, of course. But the solid rocket boosters are, okay, a little bit different. We got a little bit of time here, so let me show you. So, okay, you have like a liquid fuel rocket engine, all right? LF rocket engine, right? So the liquid fuel rocket engine has a nozzle. You have your throat, right? And then you have a combustion chamber, right? This is a standard convergent divergent rocket design. That's it. This is what Goddard figured out. So you have your throat right here, right? You have a combustion chamber, right? You have an explosion in here, right? And then the explosion gets accelerated at supersonic speeds right here. And then it goes out at subsonic speeds out the bottom. Right? You're basically just forcing an explosion through a funnel. That's it. Okay, it's rocket science. It's a little more complicated than that, but that's the general idea. That right here, how fast, the rate at which gas flows through the throat is called your mass flow rate. So that's how much your reaction mass, how fast your reaction mass goes out. And then there's exit velocity and all that stuff, and you can determine delta V from that, or a specific impulse from an engine. So this is a liquid fuel motor, right? So liquid fuel motors usually have like a pump on either side, right? They have a turbo pump. And the turbo pump is connected to a fuel tank, right? And that fuel tank usually has like a bulkhead in it. So you have liquid fuel here, and then you have oxidizer here. And then the oxidizer pipe usually comes down through the liquid fuel tank, right? Like, don't get me wrong, every rocket is a little bit different. And then the pipe comes through here, and then there's like a pickup right here for all the propellants that are in there, et cetera, right? And then the rocket's usually attached to some kind of thrust structure, okay? Right? So the liquid fuel pickup goes something like this. And these pumps, right, go in. They're a fluid impeller, like a fuel pump in a car, but it moves way more propellants way faster. They're usually driven by a jet engine, right? So you have these pumps on the sides, right? Now keep in mind, this is just one style of rocket motor, okay? You could do a bunch of different things with this. Like an expander cycle plumbing or a stage combustion cycle plumbing would look very, very different. This is similar to like an RS-68. You got 2 turbo pumps, open cycle, right? It kind of looks like an RS-68. Or a Merlin. A Merlin is kind of like this, but a Merlin has 1 turbo pump. Well, it has 2 turbo pumps on 1 shaft, so it would look like this. You have your turbo pump right here, and then it's connected to 2 impellers, right? And one is for LF, right? And the other one is for oxidizer, right? So that's kind of a liquid fuel engine. That's very basic stuff, okay? You know, you have your fuel tanks up here, and your fuel tanks the pumps are pulling from the fuel tanks, just like electronic fuel injection in a car. It's very similar. It's not similar. It moves way more fuel, but you get the idea. So let me just go here. Don't save. So an SRB, okay? How is that pressurized? Well, an SRB has a nozzle, right? It has a nozzle, it has a throat, and it has a combustion chamber. Just like a liquid fuel nozzle, SRBs are still a convergent divergent design, The thing about an SRB is that instead of having an injector right here where your liquid fuel and oxidizer comes in, SRBs work something like this. The combustion chamber is the entire solid rocket booster. And the propellant, which has the oxidizer and the fuel baked into it, literally baked, yeah, is baked on the walls. It's on the wall. And then up here, up at the very top, literally a spark plug. It's just called an igniter. Works very similar to an igniter on a propane grill. Same thing. Well, it's not the same thing, but it's the same idea. When that thing sparks, it ignites the propellant, and the propellant pressurizes the combustion chamber, and then it shoots it out the bottom. An SRB is very similar to a liquid fuel engine, except the combustion chamber is stretched over the entire booster, right? And the propellants are packed against the walls instead of in liquid form in a fuel tank. More like an Estes rocket igniter, something like that. They just need to get an electrical arc in here to light the propellants. So, yeah, SRBs are pressurized, of course. They're pressurized in the combustion chamber. Liquid fuel rockets are a little bit more complicated, but you got to remember, you could do more things with a liquid fuel rocket. Now, I'm not hating on solid rockets. I love solid rockets. Really good idea. Really simple. One moving part, the igniter. And then if you have thrust vector control, it's two moving parts. They're very simple. Liquid fuel engines, you have throttle ability with liquid fuel engines. Don't get me wrong, you could still program a thrust curve into an SRB. Trojan, how they physically pack the propellant against the walls of the SRB can denote what type of thrust output you have. You can basically, with the SRB, you could basically increase or decrease your combustion chamber volume, right? They have a dynamic combustion chamber volume because the propellant is inside of the combustion chamber, and if you burn the propellant, right, it's changing the volume of the combustion chamber. So you can throttle them back, you can throttle them down, but you got to pack the grain. Grain is the term for SRB fuel, right? You got to pack the grain inside of the SRB in a very, very certain shape. Like you could pack it in a shape that looks like the Imperial logo from Star Wars, right? And you'll get a different type of thrust curve. Over time, the booster could ramp up in thrust, it could ramp down in thrust, it could stay the same. You could do a bunch of different things, but that's like, when I say it's programmed, I mean it's basically programmed. Once you ignite it, it's gonna go on that thrust curve, and there's no stopping the programming. There's really no way to stop it unless you can figure out a way to pump a lot of inert gas inside of that combustion chamber. There are SRBs that you can shut off. There are designs for that. But SRBs really, really do better for either a first stage or a second stage for insertion. Liquid fuel engines are really good for applications up there. Liquid fuel engines they have a bunch of pluses over SRBs because they're reusable. Liquid fuel engine is like, fuel pump on a car. The SRB, if you want to reuse an SRB, you have to take it apart, repack the grain inside, and then put it back together. Like the segmented SRBs on SLS are reused from the shuttle missions, just like the shuttle motors are. So there's trade-offs. There's always trade-offs. There's always differences. But yeah, SRBs are pressurized. They absolutely are. They're pressurized inside of the combustion chamber. But the thing is, on an SRB, the entire SRB is the combustion chamber. There's no fuel tank. The fuel tank is the combustion chamber on an SRB. It's all one thing. Is there any satellite you could see during the day? Liam, you can see satellites when the sun is going down. So, like right after the sun goes down, if there's satellites in low Earth orbit, the sun is still shining on it despite it being dark where you are. So it front lights the satellites. You can see them anytime in reasonable conditions at dusk or at dawn. You see satellites all the time. You can see the ISS, no problem. SLS boosters are going to be one-time use, Van, because of infrequency of flight. If you have a problem with that, I don't blame you. I also have a problem with that. They're going to be replaced on Artemis 9. So by Artemis 9, they're going to run out of shuttle SRB casings. They're going to run out. Just like they would run out of used shuttle engines. SLS is reusing much more shuttle parts than you might think. It's using the SRB casings. It's using the RS-25s. Orion, with its service module, is using shuttle orbiter maneuvering system engines. Yeah, the Artemis 1 SLS has a bunch of shuttle parts that have flown on it. I don't like that, but whatever. I'll trade it for boots on the moon, man. That's worth it. Hybrid SRBs aren't really useful for anything, especially when you violate your TF. Yeah, Sevi, for the car fans out there, right? There are some solid rocket motor designs with a fuel injector in it, but it's not a fuel injector. Yeah, nitrous. There are some SRB designs where they shoot nitrous into the combustion chamber on an SRB, and yes, it does go faster. Transporter-4 Merkers is what's going on right now. What part of the SRB combustion chamber and what part of it is fuel tank? Yes. Did you see the picture of the SRB packing graphic I shared? Ponzister, if you know these questions, if you know the answer to these questions, why are you asking them? Genuine curiosity. Yeah, man, well, you know, you got to be careful with doing that because there might be people with actual questions that are looking for it, and I can't answer them because I'm busy ranting about things. You going to play railroads today? I'm not sure, Ansel. What's the current timeline for Artemis 1? Good question. Which one is safer? It depends on what you're doing, Spartan. Honestly, engineering is about application. So, okay, I'll give you an example. Would you use a garden hose as a fuel line on a car? Probably not. I mean, you could. Why would you, though? Just go to the store and buy fuel line, right? Why would you do that? I mean, you could. You could. It's probably not going to work very well. That's what I mean. It's all about application. You know what I mean? So, like with the shuttle, everybody's like, oh, SRBs aren't safe, blah, 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 blah. I mean, that's not really what's going on. It turns out if you don't launch the SRB in the conditions that it was designed to work in, it's not going to work correctly. I know. Big, shocking revelation. So it really depends. It depends on what you're doing. I mean, arguably after Challenger, the shuttle flew. Did you ever hear a problem about those SRB O-rings ever after that? Nope. The 3 O-ring design on the SRBs on SLS are the same thing. That should fly just fine. People are going to fly on that. SRBs aren't dangerous, guys. It's ignoring the flight envelope of the rocket and then launching it anyway. That's called normalization of deviance. That's dangerous. That's what gets people hurt. You don't want to do that. You don't want to say, I didn't really expect it to do that. It's fine. That's not good. Anyway, Panda, what's the current timeline for Artemis 1? We have the wet dress rehearsal in 3 days. The wet dress rehearsal is basically NASA validating that all of their procedures for launching and scrubbing the vehicle are good. So what is launching and scrubbing the vehicle? What does that mean? So NASA's going to go through a simulated countdown. They're basically going to practice. That's why they call it a dress rehearsal. Wet dress rehearsal wet implies fuel, okay, in rocket science. You have wet mass and you have dry mass, okay? So if they're doing a wet dress rehearsal, that means they're going to practice a launch sequence with SLS, with the Artemis 1 rocket, the big orange one that's out there. They're going to practice fueling procedures, and they're going to practice a simulated count all the way down to T-minus 10 seconds, right before the shuttle engines would turn on. And I'm still going to call them shuttle engines. They're not shuttle engines. They're RS-25s. I understand that. I'm calling them shuttle engines, okay? Right before they get ignition on the 4 engines in the center, so something like that over there on the far left screen, they're going to scrub the launch on purpose. They're going to initiate a manual override of the auto sequencer. All right, so what does that mean? They're going to stop slslaunch.exe. That's the right way to say that. No, they're not using Windows. Rockets are Linux derived. I mean, some of them are. Some of them aren't. Some of them are proprietary avionics. Every rocket's a little bit different. Every rocket uses different code. They're going to end task. But that's not the end of the wet dress rehearsal. What they're going to do after that is they're going to practice scrubbing the rocket, okay? Now, I say practice, but that's not really the right way to say it. What NASA's doing with the wet dress rehearsal mostly is making sure that the manuals that they wrote for how to launch the vehicle and how to scrub the vehicle are correct. That's the big one. They're making sure that the manual for how they wrote to use the vehicle is working correctly. They're going to make sure they got all the steps right in the manual. That's what it is. It's called it's a validation test. That's basically what they're doing. That validation test is going to show that this is all the right stuff. This is all the stuff that you need to do to get the vehicle going and launching, and this is all the right stuff that you need to do to get the vehicle to scrub, right? You want to make sure you practice safing the vehicle, because not every launch is going to go on the first time. That happens. Scrubs happen. It could be a thunderstorm. There could be a thunderstorm in Florida, a freak thunderstorm in the middle of the day, and that could scrub your launch. So NASA doesn't want to be caught with their pants down, so to speak, right? You don't want to put the rocket out on the pad and say, okay, we're ready to go. Oh, we can't go today. It's raining. How do we safe this? How do we do that? I don't know. How do we do that? I don't know is not what NASA does. They don't work that way. So they're gonna, during this wet dress rehearsal, they're gonna practice getting all the steps up to launching the vehicle, and then they're gonna practice all the steps scrubbing the vehicle too, so they know. It's gonna validate all the procedures that they have to make sure that that's the right thing to do, because you don't want to get caught with your pants down like that. And now, after the wet dress rehearsal, what they're going to do is they're going to unplug all the fuel lines. They're going to get all the fuel out of it and make sure it's scrubbed correctly. And then they're going to take SLS back up on the crawler, and they're going to bring it back to the VAB. They're going to put it back in its hangar. Now, why? Why are they going to do that? If the tests work, shouldn't you go to launch this thing? Like, if everything is good, shouldn't you launch it? Well, yes and no. Once again, it comes back to making sure that it's the right thing that you did. The first thing is, after the wet dress rehearsal and the subsequent scrubbing, they're going to review all the data in telemetry. They're going to look, because every step gets logged with rockets, every single step. You could hit the Alt F4 key and that'll get logged, right? And you'll get a stream of data, right? Like how a system administrator will get a stream of data, like on who's messing with the server or something, or who's accessing the server. Everything gets written down, coded, right? It gets outputted as telemetry, right?
Discovery, go at throttle.
What NASA's going to do is they're going to go through all the telemetry on the vehicle, through the fueling procedure and the launch procedure and then the scrubbing procedure, and make sure that data is matching what they thought it was going to do. That's the real thing with NASA's tests. NASA's tests aren't frick around and find out, let's put it on the pad and let's hit the go button and see what happens. No. That's how SpaceX tests things. And that's not a bad way to test things. If you're trying to get something done quick, that's the right way to do it. This way is a little bit more expensive than how NASA does things, but I digress. So what NASA's going to do is they're going to go through all that data and make sure that it's working exactly as intended. And then after that, they're going to roll it back to the VAB, and this is the second part. They're going to roll it back to the VAB, and then they're going to physically inspect the vehicle, because data is great. Data is fine. Data is awesome. Data of the character is also really cool too, but they're going to bring it back to the VAB, and they're going to physically look over the vehicle. They're going to go and look at it and make sure that the telemetry that they have matches the mode of the vehicle. So what does the mode of the vehicle mean? They're basically making sure that the vehicle's in the exact same configuration that it was when it left the VAB, right? Because theoretically, you moved the vehicle to the pad, so you have the mode of the vehicle that it was, the configuration that it was in when it left, right? And then you brought it out to the pad, you did your wet dress rehearsal, you did your scrub, right? And then you brought it back. It should theoretically still be the same, right? If it's not, then you got a problem. Then you're going to have to figure something out. Why did it change? What changed it? How did it change it? Where is that information in the data? Like, if NASA rolled the rocket to the pad and it was orange and they brought it back after fueling and it's green, that's obviously not intended. So you have to figure out why. Why did this happen? It's not just troubleshooting. You can't just say, oh, did you try turning it on and turning it back off again? No. You have to address root cause. If you go figure out why it turned green and what did it and how it did it and when did that happen and why was this different than what we had thought it was going to do, That stuff does happen. It's rocket science after all. This is really hard stuff. So NASA, when they test, it's not like go screw around and find out. What they do is, it's like a final exam for school. You shouldn't learn anything during a final exam. It should be testing your knowledge to make sure that you know everything. If you learned something during your final, you did something wrong. Can attest. So, after the wet dress rehearsal on the 3rd, they're going to roll the vehicle back to the VAB. They're going to make sure that it's in the exact same state, and not just the vehicle, the launch pad too, because they move the entire launch pad with SLS. They're going to make sure that the launcher and the vehicle is in the exact same configuration that it was when it left the VAB before they rolled out for wet dress. They want to make sure nothing has changed, and they want to make sure all the procedures work exactly as they thought they would. Okay? Once again, with rocket science, you really don't go, all right, well, let's see what it does. Oh, that didn't do what I wanted it to do. That's fine. Yeah, whatever. Launch it again. It's not Kerbal, man. Even though like rapid iterative testing does do that, because you learn the most if your rocket blows up, believe it or not. Like, as weird as that sounds. Rocket science is all backwards, man. It's all weird. So you have to, they have to, the way NASA does it is they have to make sure that everything that they did was right and the vehicle has stayed, the mode of the vehicle has stayed the same. You don't want to put the vehicle into a failure mode. If you put it into a failure mode, that means something changed, right? And then you go to launch anyway, and then it fails. Failure mode, right? NASA wants to make sure that doesn't happen. And their testing regime, the way they do their testing, like i.e. final exam versus frick around and find out, right? It basically ensures that should go smoothly. Now, once again, you could do everything right with a launch vehicle. You can do everything right and something will still go wrong. Apollo 12 is a good example of that. Apollo 12, they did everything right. They launched the vehicle and it got hit by a random lightning strike, and that almost fried the computer on Saturn V on the way up. They had to reroute the power systems on the launch vehicle while it was flying into space. Apollo 12 is a good example of doing everything right and still getting an unknown. It's not a bug, it's a feature coming in and screwing things up. It does happen. It's difficult, man. This stuff's tough. That's why NASA is up to the anal retentive about this stuff, about it, making sure it needs to be right. You don't want anything changed with the vehicle. The second something changes, the second you're opening up the door for failure. You can make no mistakes and still lose. That's not fair, that's life. Deal with it. One of the best quotes from that show, Hellfish. SCE, Cantab, bottom right corner. Ecom, try SCE to auxiliary. SCE to aux, what the hell is that? Do you have plans to play Distant Worlds 2? Prairie, I don't know what that game is. I've never heard of it. So, Panda, I know that was a little bit of a long explanation, but it's important for people to understand how NASA tests things. They go slow for a reason. NASA, because honestly, failures happen, dude. Failures happen with rockets. It happens. There's 1,000 bajillion different parts, and you can't predict the future. Failures do happen. Ideally, you don't want a rocket to fail, A, when people are on it, and B, in a very public way. NASA's been bitten by that bug in the past. And even that, NASA did an analysis of why that happened. And it comes back to, not making making sure that A, you're flying in the prescribed flight regime. Basically, if the engineer says, nah, probably it's not tested for that, you probably shouldn't launch in this condition, then A, you should probably listen to him, and B, if your rocket is doing something that you didn't anticipate, yeah, you should probably make sure that it doesn't do that again. If you have deviant behavior from your rocket, you don't just say, nah, it's fine, it's cool, just launch it again. That's how stuff goes wrong. And NASA, with this type of testing that they're doing, you could trace the knowledge, or not the knowledge, you could trace the the testing analysis right back to previous endeavors. Now, a little bit of a long answer, but they got to make sure it's right. You can't fail. You can't do that. Yeah, that would be extraordinarily bad. That's a big Twinkie. Tell him about the Twinkie. Tell him about the citrus rocket. That's a big orange. So they don't just send it. Got it. Yeah, you never... Orion, to be honest, not even SpaceX does that. You don't just hit the go... But you don't put something out on the pad and hit the go button. I mean, SpaceX has done that in the past, but... SpaceX has done that in the past because there's nothing to base your previous data off of. Yeah, if you're trying to do something different, you have no prior knowledge of how that rocket's supposed to fly because nothing has ever done that before. You see that type of... Every once in a while, when someone tries to push the envelope, you get a mission where they're like, all right, just go. Like STS-1, the first shuttle mission is a good example of that. You, at the end of the day, there's no way you could test the shuttle. How are you going to test it? How are you going to do a full stack test without people on board? All right, let's just test this plane with nobody on board. Whatever. Let's test this space plane with nobody. You can't do that way. Every once in a while, you just got to send it, and you got to make sure that you're at the top of your game when you do, or else it's not going to work. Buran seemed to do it all right. Yeah. Hey, man, I don't know the answer to this question. Can you help me out with this question? Yeah, here, I'll show you my answers. Just change it up a little bit. Shuttle in Buran in a nutshell. It does happen, Hellfish. Don't get me wrong. It does happen, but not very often. Anyway, let's flip back over here, see what's going on. Maragos, what's going on, buddy? Okay, we should be getting up here on Seco 3 and then deploy again. You missed it, Biz? Here, I could show a replay if you want. Here.
9, 8, 7, 6.
It's going to be
5,
condensed because we're getting up on the
4,
satellite deploy here,
3,
so.
2, 1. Mission and liftoff of Transporter-4.
I got you.
Pitching downrange.
Yep. Send
Stage
it.
1, chamber pressure is nominal.
You could hotwire the shuttle, Synerd, if you really wanted to get it to... They could remote control the shuttle, but... Think about it like this. The shuttle was designed to have a pilot and a co-pilot at the very least. And you could make it operate remote control if you really wanted to. You could do that. Heck, a lot of the shuttle's ascent systems were automated already, right? However, because it was designed to have people on board, retrofitting the shuttle to fly remote control or fly automatically to land would be like turning your car into a self-driving car if it's not a Tesla. You know what I mean? Could it be done? Sure, absolutely. Yeah, of course. Of course you could do that. The movies do it all the time. They have RC cars. They have, you know, remote control cars with the motors and servos on all the controls, so you can control it from, you know, like a toy. You could do that with the shuttle, of course. You'd have to hotwire it though, but it could work. NASA did do studies into trying to get the shuttle to fly by itself. I like how SpaceX doesn't use silly holds in the count and how if they really have to, they will recycle the count. Yeah, I don't like holding mid-terminal count, Hellfish, but if New Shepard, I know that's what you're talking about. If New Shepard was designed that way, then whatever. Guys, I'm going to pop us back up to live. It was a great ascent here. Real good. Because we're getting up on second stage engine cutoff here. Yeah, Signer, you know, everybody here says, oh, Buran was amazing. Oh, Buran was amazing. But you're saying that after one flight. After one, if the shuttle only flew once and then NASA said, screw it, we're going back to Saturn V, the shuttle would be revered as a great vehicle, right? the point that I'm trying to get at is that Buran is inherently complex. It's a very complicated system. Buran Energia is the most complicated rocket ever designed by a long shot. I think Starship is the only one that even gets close, just because of the technical complexity of the project. Buran could have had some kind of design flaw in it. I'm not saying that it did or didn't. What I'm saying is that you're never going to know if it was reliable or not, because it only flew once. The shuttle would have been 100% reliable after STS-1, and that's it. It would have been 100% reliable, but you never would have figured out what the SRB O-ring problem. There's a bunch of different things, and once again, I'm not trying to say oh, Buran's a piece of junk. I like Energia. Energia is a great launch vehicle. We should have designed something like that from the start, so you could use SLS and the shuttle at the same time. Just saying. Glushko is the guy that designed that. Valentin Glushko is very smart. Very smart to make one super heavy launch vehicle that could launch shuttles or payload into space. That was genius. It's a really good idea. But also, one flight is not nearly enough to say whether it's reliable or if it's better or not. I'm sorry, it's not. You could say, well, but the remote control, it's not. You don't know. It could have a design flaw in it. I still think they should have kept the RD-0120 around. Yeah, that would have been great. All right, we're coming up on second stage engine start 3 here. Yeah, I can't tab something like that, dude. I'm going to go to this side of the screen, guys, so you can see the telemetry. They're out. Actually, they're almost flying over where India's space program launches from. They launch from over here. I can infer what hot wiring means here, but man, I can only imagine some dude was sneaking into a space shuttle and stealing it. Yeah. I mean, the shuttle has a flight computer. It could land by itself. You would just need to give it something to look for. And then you would have to wire in some kind of system for it to be able to find the runway. Because the shuttle, during the last stages of descent, so when it turns and gets aligned with the runway, that's all done by people. So it's technically a closed loop system because it's using internal guidance. Your eyeballs looking at the runway. Oh, there was a shot of LOX tank right there for a second. Did you see it? Did you see it? Who saw it? Oh, there's another shot. That's inside of the second stage fuel tank.
Welcome back to Transporter-4. If you've been following along so far, we had a nominal mission so far, and
back engine shut down.
Okay.
We just had that quick last third burn, which was only about 1 second long.
Interesting, Sister.
We are waiting for confirmation of that good orbit from SES-3 and SECO-3.
Nominal orbit insertion.
Okay, we have an OI.
There's the confirmation of a good orbit there.
It looks like they were up on the timeline
our first 3
there.
deployments, our next 9 deployments are also going to happen during a blackout period, which means we lose camera views and telemetry. But to see the full list of deployments, head over to SpaceX.com. And while we wait to regain access to ground station coverage in a few minutes, sit back and follow along with our animation that shows you where we are in the mission. And we'll be back here at T+1 hour and 18 minutes.
Oh, all right, Jock. Oh, we'll take a look at it if we have time. That's cool. That's the end map. That's the first payload that they deployed, huh?
And acquisition of signal, Dubai.
Okay. SpaceX has a tracking station in Dubai. I didn't know that. Cool. Yeah, look at that. The stage was up at 650 and now it's down at 500. That's cool, man. This is a super
Expected loss of signal, Maldives.
Maldives. That's really cool. They this is a hard mission, man. The difficulty on this is pretty cool. A testament to the people at SpaceX that are working in the guidance department. This is a tough one. They have 40 satellites on board, guys. They got to deploy Some of those satellites need to go to one orbit, some of them need to go to another orbit, some need to go to another orbit. That's really, really crazy stuff. Yeah, and KSP type stuff for sure. What is our place, Potato Bot? Also, Potato Bot, you think I should go give Waffle a ring and see if I know it. I saw that he bought tickets to the F1 race. Want to see? Should I go? Should I go with him? Send him a message. Hey, space for one more. I mean, if you want my ugly mug with him, you freaking, I'd go, but yeah. I was thinking about shooting him a message. Hey, I'll buy, dude. Where's your tickets? I'll buy tickets. We'll go. It'll be fun. Do you have time to show the best 1 minute 11 seconds of Rocket TV? The guy presenting it had one take to make this no green screen. That's James Burke, Baramus. Yeah. All of it combining to do that. Yeah. Yeah. That's a great video. Tickets for the Formula 1 race. Oh, our place. Interesting. That's a great video, Baramus, yeah. I'm wondering if they'd ever think of putting small-scale hypergolic RCS based on Dragon hardware in order to get the ability to deploy a bunch of satellites to different orbits. That's what I'd do if I was building the rocket in KSP at least. Something like Fregat. Dragon XL should do something like that. But I've heard nothing about Dragon XL in a long time. But yeah, Signer, if SpaceX ever decided, and I don't think they would, but if they ever decided to convert the trunk into a service module, Dragon would be really, really good. Yeah, real good. Destination, to the moon or Moscow. Yeah. I think Coda, Dinkelberg.
Expected loss of signal, Bangalore.
What are your thoughts on the Vegas race as an American? I think it's another bad street track, which will kick a classic European track off. I get it's a good event for entertainment. Hey, Elro, 38-month resub. The F1, I don't mind the Vegas track hand. Guys, you gotta remember that the Formula 1 cars race differently nowadays. Lots of straights are good for these cars because you're gonna get a lot of racing. And I'm pretty damn sure that that track is designed to get a lot of racing on the strip. I don't think that's an accident. Just a thought. With that being said, look, man, I ain't new to Formula 1. I ain't new to Formula 1, and I know the significance that the European tracks have. Hockenheim, Spa, many cores, which they don't race anymore. Silverstone, the Hungaroring, like, those are the classic F1 tracks. They should not get rid of those. Hey, Warrior, what's going on? Spa should never leave, like, Monza, Imola. Those tracks should never leave the Formula 1 circuit. I'm sorry. It would be like the Red Sox not playing at Fenway Park. I'm sorry, that can't happen. That's not... Anybody that tries to say that, I think is wrong. Yeah, Paul Richard is an okay track hand, but they ruined it by making it a parking lot. There's so much runoff everywhere, you don't even need to drive the track. If Paul Richard went back to using the gravel traps, it would be a good track, but it'd be dangerous. Personally, guys, I'll be honest with you. These 2022 cars on old Hockenheim would be absurd. That would be an absurd race. It would be insane. It would be absolutely insane. There would be passing all over the place. I mean, I'm not going to lie. Someone would probably get hurt. But, Hungary is a contract for the next 15 years. We ain't going anywhere. Bauxy, Hungaroring is a good track. Straight up. It's a good track. Really. My thing with the Hungaroring is that it needs to be a little bit wider in some areas. It's really difficult to pass someone on that track because it's narrow. But simultaneously, it being narrow is what makes the track fun. It's a good track, dude. I really don't mind it. Monaco will never leave, as they would never be able to go back. If they did, it would only be on the calendar because grandfathering over safety. Yeah. I want F1 back at the Glen. You'd need to redo the entire track at this point, Dinkelberg. But yeah, I agree. It'd be cool. Red Sox not playing at Fenway is a federal offense punishable by 100 years in prison. That's right, man. Dude, Warrior, have you seen the Sox, man? They already have like 20 home runs or something ridiculous. It's like, okay. They on a mission, man. They got screwed last year. Damn umpires. Why don't they race F1s at Road America? I think they should do that, Frilled. The new F1 cars at Road America would be absurd. That would be really fun. You would need to be careful, though. Track's very bumpy for those Formula 1 cars. Deployments are underway. Here we go. I disagree. Sector 1 is literally perfect for battling. Yeah, Sector 1's okay. 2 and 3 are tough, man. It's tough. Bouncy. I mean, whatever. It doesn't matter. It's semantics at this point. I think the Hungaroring is a good track, and I think with the new Formula 1 cars, it's going to make racing really good. I mean, if it was me, guys, I wouldn't go changing tracks in Formula 1 right now. Okay, there's a blackout here with the ground stations right now, fellas. But Road America isn't a grade 1 track? I'm not sure, Richter. I'm going to go ahead and guess that it's probably not up to FIA spec, because most American tracks aren't, with the exception of COTA, right? But I don't know for sure. Someone's going to have to fact check me on that. I like Formula 1, but I know spaceflight. Like, this is the stuff I'm sure about. I'm not sure about Road America. Either way, I'll tell you what, man. The NASCAR race at Road America last year was awesome. And even though, you know, like, I'm a Ford guy, so seeing Chase win, I mean, I like Chase Elliott. His dad was pretty cool. Pretty big Ford guy, but it was still a fun race to watch. Even NASCAR at COTA this year was amazing. It was really good. Please see last. It'd be the same with the Glen. Too much would be needed to done to make it suitable. Yeah. It sounded like a true Sox fan. I blame somebody else. That call was terrible, Hibbit. You could say blame somebody else. That call was horrid. But we did collapse like a house of cards after it because the call was so bad. What is Transporter-4? Transporter-4 is a rideshare mission. It's a bunch of small satellites that SpaceX is deploying right now. We don't have a picture of it because they're over...
Welcome back to the webcast for Transporter-4, SpaceX's fourth dedicated small sat rideshare
There's no
program
ground stations
mission.
up here.
We had a successful liftoff at 12:24 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. As I mentioned, this is our fourth dedicated rideshare mission. Our goal with these rideshare flights is to provide small satellite operators with the competitive pricing, increased flight opportunities, and flexibility.
There you go,
These dedicated rideshare flights to sun-synchronous
it.
orbit will occur around 3 times a year, providing regular access to orbit. Additionally, we also offer opportunities for a ride to orbit on our Starlink missions, which launch every couple weeks or so.
What's up, Clay?
So we have 40 spacecraft on board today's mission, spanning across 20 deployments. That includes CubeSats, microsats, picosats, non-deploying hosted payloads, and an orbital transfer vehicle carrying spacecraft to be deployed at a later time. So far, we've had 3 confirmed separation events and are currently waiting to hear the call-outs for another 9, which occurred during a blackout period with no access to ground station coverage. Now again, to see a full list of all deployments, head over to SpaceX.com. Now let's listen in to hear the confirmation
there weren't
of those
Russian
9
ground
deployments
stations over there to
here
begin with,
shortly.
Pixel. They're up over near the Kola Peninsula up here. That's way up north, man.
Now we should get
way
that
up north.
confirmation.
9 payload separations confirmed.
Okay.
There we just got that confirmation of...
Acquisition signal, forward.
of
Svalbard,
9 confirmed
Norway.
payload separations and a brief glimpse from that Falcon second stage. That confirms the second set of deployments. So far, we've had 12 out of 20 successful deployments. And in just under a minute, we are about to start our last batch of 8 deployments. So over the next few minutes or so, we are expecting to hear the call-outs for the remaining 8
They're
deployments.
spinning around that second stage. See the
It's also
shadows?
worth mentioning that because many
Or
of the spacecraft are being
that
deployed
could be the shadow
in
from
groups,
a
we may
satellite.
not be able to confirm every deployment in real time, but you should hear most of the deployments called out by the operators on console. But for any we don't hear,
25, separation confirmed.
there's that first one. But if there's any you don't hear in real time, we will provide, we'll try to
these
provide
little
updates
guys?
by the close of the webcast.
They're all little satellites.
Let's listen in.
So this big cylindric thing, that's a payload attachment fitting, or PAF. The PAF has radially mounted attachment points. You can see one of them that's open right here. That already deployed a satellite. Or actually, that might be the satellite, and that black ring right there might be the deployment. I'm not sure. But this transporter mission, guys, is basically a bunch of small satellites just all ride-sharing on... it's called a rideshare mission. They're all ride-sharing on one Falcon 9. So it's a bunch of tiny little satellites that are being kind of grouped together on this big payload attachment fitting that... I mean, the PAF looks like a giant Christmas tree. And these are all the decorations, and it'll deploy all of them on there. Let's see. We're coming up on another deploy here. I'm not sure. You know, if we get a good view, you're going to see one of these things pop off here. It'll spring off. Yeah, Steiner, it's true. That's basically what a payload attachment fitting is. I wonder if they all split the cost of launch equally. Yeah, rideshare missions generally bring the cost down because Falcon 9's already an inexpensive vehicle, and then splitting the cost of the vehicle with a reused stage, etc., you split the cost of the vehicle combined with SpaceX's reusability, and honestly, putting your small sat with a bunch of other small sats on this big rocket is comparable with you buying one smaller rocket to launch just your payload. So this rideshare mission is comparable with all the small sat launchers that are around. That's the competition. Nmap is working. Nice. Okay, we got 4 more deploys here coming up on the mission timeline. Let's listen for the flight controllers to call it out. Oh, there it goes. See ya. See ya. There it goes. Bye-bye.
26, separation confirmed.
Okay. Rideshare is available as low as 1.1 million for up to 200 kilograms. That's you won't find a better price to send something into orbit, Subby. That's about as low as it goes right now. Yeah, you could see the reflection of the satellite. Oh, ooh, secondary picture. All right. Oh, that was the other side of the PAF. They hadn't shown that yet. This one right here. Let's see. They're gonna lop one of these things off here. There it goes. Bye-bye.
Hawk 4C, separation confirmed.
I'm gonna move me over here so you guys can see the payloads deploying. Oh, there it goes. Bye-bye.
Hawk 4B, separation confirmed.
I think this one is the next one to go. That's 4C. If I'm hearing this call right, I think that one is the guy that's gonna go right now. Come on. Hello? Yes, this is Dog. The reason why I think that's the next one that's going to go is because the 2 satellites that... Oh, there. Yep, okay. There's 2 of them there. I was half right. Wrong formula, right
Hawk
answer.
4A, separation confirmed.
Okay. And now that one looks like the same type of satellite. That's why I said that up here is going to be the next one to deploy, because it looks like all the other ones. It looks like it's a constellation of satellites.
Acquisition of the signal, Thule.
Thule. All right. I just want to point out that we're watching a live stream of payloads being deployed on a rocket that's traveling 17,000 miles an hour around Earth. And that's being live streamed to your computer right now. I just you know, like, it's good to be introspective at times, right? To kind of just remember what's going on here. We're literally watching satellites deploy on a rocket going around Earth in near real time. Probably uses Starlink. They're using ground stations, drummer. They are calling out the ground stations. Yeah, that's, you know what? I'll take this part of the future. I like this part. We should keep this part. We should keep doing this. It's a good part of the future. Even the video? Considering they only show video when they're in range of a ground station, I would say probably yes. Oh, bye-bye. See ya.
MP42, separation confirmed.
I mean, that's my guess, drummer. Like, only relaying what they said. Oh, there goes the pizza plate. Bye-bye.
Link, separation confirmed.
Pizza box. Pizza box satellite. I want to see that big chonker up there go. Oh, well there it goes. Oh, look at its little thrusters. See, it's got a...
SCV-005, Almighty Alexius, separation confirmed.
That's the name of that thing? Okay. And it's gone.
With that concludes our deployment sequence. We were able to confirm all 20 deployments today. Falcon 9 really wasn't fooling around. And
yeah,
with
right?
that, we would like to thank all of our rideshare customers for their support on today's mission. For a full list of the deployments today, head over to SpaceX.com. We would also like to thank the United States Air Force for range support, as well as the Federal Aviation Administration for licensing. Continue to follow us on SpaceX.com for future missions and
look at that view of the North Pole,
as well as Twitter and Instagram. And if you're excited about
that's
what
pretty
you see
neat
today and want to join our team, visit SpaceX.com.
All computer controlled, Phil.
To learn more about working here at SpaceX. Thank you to all.
So basically, every Falcon 9 has a modular software architecture, and basically you input parameters, right, for where the rocket's going to go, and then the deployment sequence is custom coded pretty much every time. But SpaceX does use modular code. I know that, like, depending on where Falcon 9's going, what its mission is, they'll add more to it. This one probably has a little bit of a more lines of code than other missions because of all the different satellites they need to deploy and the multiple orbits that the stage needs to go to. North Pole, wasn't that Greenland? Yeah. Yeah. Greenland, what's that near, Zizep? Refresh my memory. What's Greenland near? Oh, the North Pole, that's right. Yeah. Yeah. It was the northern parts of Greenland, yeah. It's near Greenland, obviously. Render of SE-05 deploying sats. Dude, that thing, that big boy satellite is a small sat launcher in itself. So a small sat launcher is launching a small sat launcher into, a big rocket with a rideshare mission is launching a small sat launcher into space. Look at, yeah, see, dispensers. Yeah, little dispensers. It's like a space filing cabinet, but with satellites. Why is Greenland white? It's because Danish people don't know how to name things correctly. Oh, look at this place. Oh, it's very white. We will call it Greenland. It's weird, man. I don't know, man. I don't know. Nobody knows what they're doing up there. It's very strange. Because Iceland was already taken. Oh, we found a place with more ice. And by a few of those a year for July 4th. Yeah, of course. I don't know, Signard, maybe. Anyway, somebody asked another question called library. It's an orbital transfer vehicle made to deorbit. Right on. Basically looking over Danish land. Yeah. Yes. You just made me laugh. I don't know, man. You guys got it wrong. What are you doing? We were drunk on meat and high on mushroom. Yeah, okay. That makes sense. Look at this game. What's that, Linus? Well, that's pretty neat. Here's a PDF about it. That's cool, man. It's a little space filing cabinet. Pretty neat. Anyway, that's going to do it for the Transporter-4 mission. I hope you guys enjoyed it. That was fun. Fellas, I would normally jump into regular hours now, but I have some stuff that I have to do. I will be back for Space News, though. I'll be honest, I'm going and touring a house because I'm trying to get out of apartment because apartment is annoying because people live near me. Trying to move into house so people are not near me. Yeah, that was a sentence. Let's go. See last. Not sold yet? No, not yet. I'm trying to tour it, and we're gonna see if we like it. Oh, nice, W. That's cool. So that's my life goal: own a home so I don't have to live near other people. Jack, I finally got to the point where I'm at the threshold to get there. Let's hope. Let's hope. Happy housing. Good luck. Thanks, guys. I appreciate it. For the long-term viewers, people that have been watching a long time, you know that this is a big deal. Anyway, when I get back, we'll talk about space news, and then we have racing tonight. We're doing an endurance race at Sebring. So we have Eric Johnson Racing Administration Le Mans Race 2. We have a tournament that's set up. We have a whole race season set up. So, and points are awarded every race. Like, it's just for bragging rights. But yeah, this is race number 2 in the EJ Racing Series Le Mans. Mission control looks so empty. And it's Gary. Gary scared everybody away because he just talks too much, man. Bring your pain meds. Oh, God, no. So let's see who's still streaming. Let's see who's out and about. I don't really ever raid anybody at this time of day. You will need practice. I'll be fine. Max, look, I can practice for 3 hours. I can practice for 5 hours. I'm still going to mess it up. I've come to terms with that, so. Red Munchkin? Sure. We can, yeah, Red Munchkin.